Alright, so I want to help you with our worksheet for today. So I'm looking at this first section on the setup. That was another video. So helping you calculate the speed here. Remember that the distance is that little flag on the car, and the flag was 1 centimeter, and so we need it in meters, so that's 0.01 meters. So use that for your distance when you're calculating speed. Remember, speed is distance over time, and the time for speed at A will be the time from photo gate A, and for B it'll be the time from photo gate B. So then section 2 here, all these the thinking about what you observed, I want to see what you guys think. They're conceptual questions, and I'm curious how that goes. And then on the next page, so the formula for the acceleration of the car in terms of the speeds at photo gate A and B. Okay, so remember the acceleration is change of velocity over the change of time. So for change of velocity, we're talking speeds here, but so change of speed is fine. You're going to have the speed at photo gate B minus the speed at photo gate A, because that's the change part. And then the change of time is going to be the time from A to B. That recorded the time for us. So then you guys can calculate the acceleration in both sections, in the level part and the downhill part, using the table from this first page, this table. Okay, then I want to help you with the graph mostly. So again, down here, distance is 0.01, anywhere we're trying to calculate speed with this little car that we have. So I want to look at the graph. Okay, it's the speed versus time graph, and we're using speed B. Okay, so we're plotting speed B on the y-axis, and then on the x-axis we're doing time A to B. And so I want you to scale your graph this way also. So along the x-axis I skipped every 5 tick marks, and I went 0.1, 0.2, 0.3, 0.4, and then make sure you label what the axis is. And then on the y-axis I skipped every 2 and counted 0.2, 0.4, 0.6, and so on. Okay, so you can plot your graph that way. Alright, and then this part, calculating the force, this is section 4B. So they say to measure the acceleration from your speed versus time graph. But so I just want to show you how I would do this. So you want to do speed B minus speed A divided by the time A to B. This is going to be your acceleration. Okay, and once you have your acceleration, then you can do what they said in the instructions and use Newton's second law. So that's F equals ma. So use F equals ma. We measured the mass. They told you to measure the mass in section 3, question 3. So you have the mass, you have acceleration. You can plug those in and find force. So you're going to do this in every step, every position that the car was in, or that the photo gate was in. So you'll do that 7 times to calculate all these different forces here. But you know they only have 6 here. So you might have to add an extra box on the end. Okay, and then the position is just the position from your table. It was how many centimeters apart the photo gates were. Okay, then you're going to plot your forces. So again, I should have a title for my graph. We'll just go force versus time. Okay, so I've got force on the y-axis. It's in newtons. Make sure you label that. And I skipped every 2 and counted 0.05, 0.10, 0.15, 0.20, and so on. And then on the x-axis, it's that time A to B again. And I labeled it exactly the same as the graph before, because we want to be able to line them up one above the other and compare the sections of this graph. So you'll be able to see a pattern like the stuff in between, like say 0 and 0.3, maybe they line up in both graphs. That you want the times to match up so that you can see patterns between the speed and the force. So we need the graphs to look the same on this x-axis so we can compare the times. Alright, and then so there's the relationship bit. So I want you to see what you think about that. Okay, and then explain how speed and acceleration are different. That will come from those questions where we calculated the acceleration using the speed. That'll help you figure out the difference between them. Okay, so if you guys have questions on graphing or anything like that, with your particular data especially, definitely let me know. And I will be on Blue Jeans the whole time.